All right, in this lesson in 10.6, we're going to look at circles and arcs. First of all, the definition of a circle: set of all points equidistant from a given point called the center. So every circle will have a center. It's going to have a radius, which is the segment that has one endpoint at the center of the circle and the other endpoint on the circle. We have a diameter. It's going to be a segment that contains the center of the circle and has both endpoints on the circle, like AB. AB is a diameter. PC is a radius. Congruent circles have congruent radii, which means they have the same radius length. And a central angle, which we've discussed before, is an angle whose vertex is at the center of the circle. So this right here, this purple arc, this is angle APC. We name it by a point on the circle. The center is the vertex and the other point on the circle. And this is the arc we're talking about. This is a central angle. So we can find the length of a part of a circle's circumference, which is what's called the arc, by relating it to an angle in the circle. An arc is part of a circle. Now let's talk about arcs. There's three different types of arcs. The first one is a semicircle. It's half of a circle. You have a minor arc, which is going to be smaller than a semicircle, or smaller than half a circle, and a major arc, which is larger than a semicircle. So you name a minor arc by its endpoints, just 2 points, and a major arc or a semicircle by its endpoint and another point on the arc. So in this case here, if you're looking down here, we have arc STR. That is a major arc. It's got 3 letters, or it could be a semicircle, but based on where the location of our points are, it is a major arc. We have S, we have T, and then we have R. You can think of it like a road map. I'm starting at S. I'm going to go through T to get all the way to R. Now, if you do a minor arc is much smaller. We want to take the shortest route in a minor arc, which means we're going to go from R to S. So we're going to take that short route. We have 2 letters. We're going from here. We're not going anywhere between, and we're stopping at S. So that is our minor arc. So let's practice naming some of these. First question says, what are the minor arcs of circle A? So as you look here, let's see what you come up with. All right, good. I'm sure you guessed this first one. The first one we could say is RS. Now, this is the arc symbol. It's a little curved line here. It doesn't have 2 or 3, just 1. Okay, this arc right here, that describes an arc. So the second one, and you can also call this SR. Either way, same arc, 2 different ways to name it. The next one is we go around our circle. We can go from S to P. So we'll call this SP. That is less than half the circle. Now the next one we can actually start at S again and go from S all the way to Q. Still less than a whole circle or half a circle, so it is still a minor arc. So we've got RS, we have SP, we have SQ. Now we can go PQ. And then we can go over here to Q and go to R, so that is going to be our last one here, which is QR. So we've gone around our circle naming all of our minor arcs. Remember, in a minor arc, they only use 2 letters. Now what is a semicircle? So if we look here, we have 2 semicircles. RP is a diameter. It goes from one side to the other of the circle, and it goes to the center. So we can name this. To name a semicircle, we need to decide, am I going this way to get from R to P, or am I going to go this way? So that's where we have to describe that third letter. So we're going to say we're going to go RSP. That tells me I'm going to start at R, I'm going to go through S, and I'm going to stop at P. So I'm going to go to this side of the arc. Now the other semicircle is going to go from this direction. That means we're going to go from R to Q to P. And that is the other arc. So for every diameter, you're going to have 2 semicircles. One above it or to the left of it, one below it or to the right of it. So those are our only 2 semicircles in this example. Now let's look at the major arcs. Now for every minor arc, there's a major arc with the same endpoints. which means if we take a look at the first one, we have R and we're going to have S. We're going to start at R, we're going to end at S, but instead of going the short route, we're going to take the long route. So we're going to go from R to get to S, but we're going to go around the other way. So I have to choose a point in between. You can choose Q or you can choose P. It does not matter. So I'm going to choose P. So it's going to be, well, not R, RPS. So RPS is a major arc. And now we can look at the next one. We have SP. So we're going to have S, and P is our minor arc, so our major arc is going to go in this direction here. This time we can choose to go through R, or we can say we're going to go through Q. We're still going through both, but you only have to name one. So let's go with R, SRP. So that's telling me I'm going to go from S through R and ending at P. You wouldn't use 4 letters. You could just choose one of the two, even if there's one in between. So the next one here we said was SQ. So we have S and we're going to have Q. So we're looking for the point in between. If I want to go, this is our minor arc, so this is going to be my major arc, which means it's going to have to be S, R, Q. Starting at S, going through R, and ending at Q. So if we look at our next one here, we've done our first 3. We've got PQ. So we're going to have an endpoint P, an endpoint Q, and we got to pick the point in between. So we're starting at P. Instead of going from P to Q here, we're going to go this direction here. And so let's choose S. So we have PSQ. So in these that have 2 options, you can actually choose, this could have been PRQ, and it's describing the same arc, so you only have to write it once. And so the last one here is QR. Q and R. And the point in between can be either P or S. So we'll go with P, and we have QPR. You could have also said QSR, and it's talking about the same arc. All right, so that is just a sample of how we write our minor arcs. It's also how you're going to read your minor, major, and semicircles. So let's move on to the next part. Arc measure. This is where we're talking about the angle of the arc. So the measure of a minor arc is equal to the measure of its corresponding central angle. So, once again, the measure of a minor arc is equal to the measure of its corresponding central angle. So the arc, if the central angle is 50 here, the arc RT, which it opens up to, is the same 50 degrees. The measure of a major arc is the measure of the minor arc subtracted from 360. 360 because it's a full circle, 360 degrees in a circle, and so we're going to find the remaining arc RQT or TQR, which is going to give us 360 minus 50, which is going to give us 310. Now the measure of a semicircle, which is also half a circle, is 180 degrees. Adjacent arcs are arcs that have of the same circle that have exactly one point in common. For example, the arcs here, we have arc ABC, this arc A and B, and then we have arc B and C, and they both share the common endpoint B. So the measure of an arc formed by 2 adjacent arcs is the sum of the 2 arcs. So the measure of arc ABC is the measure of arc AB plus the measure of arc BC, and that gives us our entire arc of ABC. So let's look here at example 2. Now, in this problem right here, well, let's see, something's going on here. There we go. All right, so we're going to look here at this diagram. Now, it's asking us for the measure of the arcs. Now, my suggestion is to go and fill all the arcs out, all the way around, and then you can go back and answer your questions much easier. So let's take a look at this drawing here. We have a 32 degree central angle, which means this arc that it opens up to is also 32 degrees. We have a 58 degree angle from C to D. Now one thing we need to notice is that this line CA goes through the circle but at the center, which means it's a diameter. So it means that this half is equal to 180 degrees. This half is equal to 180 degrees. So in order to find this arc right here, I'm going to take 180 minus the 58, and that's going to give me 122 degrees. So that means the arc from here to here, which is arc DA, is 122 degrees. So now we have to, only arc we have to fill in is arc AB. And because this is the diameter, this means this side is also 180. So it's going to be 180 minus 32. So we take 180 minus 32, and that's going to give us 148. So this arc has 148 degrees. And so we've got them all filled out. Now we can go answer our questions. Arc BC, well, that's this arc here, which is going to be 32 degrees. Arc BD, which is going to go from B to D here. Shortest distance here, which means we got to add two arcs together, two adjacent arcs, 32 plus 58. So 32 plus 58, add those together, and that gives us 90 degrees. So the measure of arc BD is 90 degrees. Now we're going to look at arc ABC. So we have A to B to C. Now we just said that this was a diameter, so that means this is going to equal 180 degrees. And the last one, arc AB. Well, we found AB earlier by subtracting 180 minus arc BC, which is 32. And that's going to give us 148 degrees. So that gives us all of our missing arcs. So it's much easier to fill out your entire circle first and then come back and solve these. So let's go to the next part. Example 2b. Find the measure of all the arcs in this circle and then go through and answer the question. So pause the video and then come back and see how you did. Okay, so as we go fill out this circle, we have, this is a central angle of 77 degrees, which means arc PR is also 77. And PS is a diameter, so that means that we would take 180 minus 77 to get arc 103. Over here we could do also 180 minus 28, which gives us 152. So we go over to answer our questions. Arc PR, 77 degrees. The measure of arc RS, well, we found that to be 103. Now we have the measure of arc P, Q, and R. So I want to end up at R going through Q. So that's the entire circle except for 77 degrees. So we take 360 minus 77 and get 283. And then the last one, there's a couple ways to solve this. It's P, Q, and then R. Excuse me, PRQ, going this direction here. So since this is a diameter, we can take, we know this is 180, we can add 28 to that, and that gives us 208. Or, since PQ is a minor arc and PRQ is its major arc, it could be 360 minus the 152. And that would also get us 208. All right, so let's move to the circumference. The circumference of a circle is the distance around the circle. It's the perimeter of the circle. The number pi is the ratio of the circumference of the circle to its diameter. The circumference of a circle is pi times the diameter. So we have two equations for circumference, pi times diameter or 2 times pi times the radius. So let's look at example 3. A car has a circular turning radius of 16.1 feet. The two sets of tires, as they travel around the circle, form concentric circles. The distance between the two front tires is 4.7 feet. How much further does a tire on the outside of the turn travel than a tire on the inside? Round to the nearest foot. So we've got two different radiuses. We're going to look at two different circumferences and we're going to subtract to find our difference. So the first thing we're going to do is we're going to identify the radius of the outside, and then we're going to identify the radius of the inside circle. The radius of the outside circle was given to us as it is 16.1 feet. The radius of the inside circle is going to be 16.1 minus the 4.7, because that's how far apart the wheels are. And that number is going to come out to be, excuse me, approximately 11.4. So that is our inside radius. We have our outside radius. So now we're going to do the circumference. And the formula for the circumference is C is equal to 2 pi times the radius. So the circumference of the outside is going to be 2 times pi times 16.1. Calculate this by multiplying it by 2. and we're going to get 32.2 pi. So we're going to leave it like this for right now. We'll calculate the pi value in just a minute. So now we're going to do the same thing for the inside circle. We have 2 times pi times the radius. Well, radius of this is 11.4. And that means the circumference of the outside is equal to 2 times 11.4, which is going to be 22.8. So to find our total value here, and this is going to be pi. Since they both have pi, we can subtract them. So the difference in circumference is going to be 32.2 pi minus 22.8 pi. And the only reason we can subtract these is because they both have pi. So we do 32.2 minus 22.8. And that's going to give us 9.4 pi. Now the next step is to calculate this. It says round to the nearest foot. So we do 9.4. So we'll turn the calculator on, 9.4. And we're going to multiply this by pi. That gives us 29.53. So round to the nearest, let's see, what do we say? Round to the nearest foot is going to be approximately 30 feet. So approximately 30 feet in distance around. All right, so now that we talked about circumference, let's use the circumference to help us find the arc length. The measure of an arc, which is that piece of the circle, is a fraction of the circumference. It's only part of the full circumference. Circumference is the distance all the way around. We're just talking about just a small piece. So the length of an arc of a circle is the product of the ratio of the measure of the arc over the 360, because there's 360 degrees in a circle, and the circumference of the circle. So we have the length of arc AB is equal to the measure of arc AB, which is how many degrees it is. Length is referring to the distance. When you see the M, it's measure. That means it's the how many degrees is it over 360 times the circumference. So you can do it times 2 pi r, or you can do it times pi times diameter. So let's take a look at example 4. What is the length of each arc shown in red? Well, the arc shown in red here is also can be said as xy. So the first thing we're going to do is we need to locate what is the radius. What did they give us? They gave us a diameter, which is 16. So it means the radius would then be 8. And so circumference is going to be 2 times pi times 8. So the circumference is going to be 16 pi. So now we're going to look at how many degrees this is. This arc xy has a degree measure of 90 degrees. It's a right angle. So we will then take this arc measure over 360, and we're going to multiply with the circumference, which is 16 pi. So we put that over 1 to help us get our proportion. So now we want to simplify. So we can mark out the zeros, and now we have 9 over 36. Well, 9 does in fact go into 36, so it goes in here to 9 once, and it goes into 36 4 times. And now we can see that 4 is going to go into 16 4 times. So we get 1 times 4 times pi over 1 times 1 is 1. So it becomes 4 pi over 1, which you don't have to put the 1. And so this is going to be 4 pi inches. And this isn't not squared, it's just in this length here, so it's 4 pi inches. Always make sure you look to see how they're asking for the question. Is it in terms of pi, or are you going to calculate pi and round off? So I want you guys to try part B. You're going to find the measure of arc XPY, which is arc 240 degrees. The radius is 15. So pause the video, work it out, and see what you got. All right, so they give us the radius of 15, plug it into a circumference formula, and get 2 times 15 times pi, which is 30 pi. So now we put the measure of the arc that we're looking for, and it's going to be 240 over 360. Get rid of the zeros. We get 24 over 36, and 12 goes into both. 12 goes into 24 2 times, and 12 goes into 36 3 times. So now we can see that 3 goes into 30 10 times, so we get 2 times 10 times pi, which is 20 pi centimeters. This is called simplifying before you multiply. So remember, once again, make sure you pay attention closely to how they want your answer. So let's look at our last example. Part C, what is the length of a semicircle with radius 1.3 meters? Leave your answer in terms of pi. So pause the video and work this. All right, so let's see here. We have a semicircle with a radius of 1.3. So we write it in our radius, 1.3. Now we're going to find our circumference. That's going to be 2 times 1.3 times pi. Remember, the circumference is 2 pi times the radius. So 2 times 1.3 is going to give us 2.6 pi. That is our circumference. So now we're going to plug this into our equation. Well, a semicircle is 180 degrees over 360. And we're going to multiply this by the circumference, which is 2.6 pi. Put it over 1. Now simplify this expression. The zeros cancel. We have 18 over 36. So we know that 18 is half of 36, so we're going to say this is 1, this is going to be 2. You could have also said 180 over 360 is 1/2. So now 2 goes into 2.6. They're both points are even, so we can say it goes into 2.6 1.3 times. So the answer is going to be 1.3 pi meters. All right, so this concludes our lesson on arcs and circles.